Okay, this is the last part of chapter 1. We're looking at section 1.3, which is all about extracting energy from our biomass. So remember from 1.2, biomass is the total weight of a species in an area. So if we looked at the biomass of grass in an area, it means we would take all the grass, put it on a scale, and weigh it. Or if we looked at the biomass of lions, we would take every single lion in an area, put them on a scale, and weigh them. And that's how biomass is really determined. A really cool way to extract energy from biomass is when I went to Costa Rica, we got to meet this cool little pig here. Her name was Sophie. And Sophie loved doing a lot of things, but one of the things Sophie really liked doing was pooping, and she was awesome at it. She was so good, in fact, that some of the sustainable farmers, like this man here, decided that they were going to harvest some of the manure produced by Sophie. And what they did is they built a container over here to the top right where they would store some of Sophie's poop. And they would mix it with water to help aid in decomposition. And if you think about decomposing, it's when we let bacteria eat away at some of the dead or deceased products emitted by animals. So they would mix Sophie's poop with water, put it into this giant bag here, and the bacteria would start eating away at it. But what was interesting is when the bacteria started eating away at it, as part of the decomposition process, it produced methane gas. And that is where these tubes come in. So this methane gas is actually an excellent thing if you use it correctly. See, methane is used to heat our homes. It's used as a hydrocarbon fuel that can be used to cook food on a stove or provide heat. But it's also very, very bad if it gets into the environment. It's a leading greenhouse gas emission. So we try to reduce the amount of methane gas in our environment. So what they did is they trapped all the methane gas in the bag, sent it onto these tubes, and sent it into the kitchen. And it was used to help cook lots of the meals we ate while we were on this farm, which is, some people might think it's disgusting. I think it's so, so cool. So a really sustainable way to extract some energy from our biomass. Sophie, the pig. So you remember from yesterday that cellular respiration is a very, very important thing. And remember, it's the exact opposite of photosynthesis. That's why we call it complementary, because they need each other. So we have glucose and oxygen. So think about it. When you breathe, you need energy, which is our glucose, and you need to breathe oxygen. And you turn those two things into carbon dioxide, which is what you breathe out, and you also breathe out some water. So I'll give you a sec to copy this down. This is the same thing from yesterday. We just want to make sure we have this. So if I'm going too fast, please just pause it and allow everybody to copy. Okay, greenhouse gases. So we're going to talk about the greenhouse effect. There's many greenhouse gases in our atmosphere. So some examples, we're looking at things like carbon dioxide. We're always talking about reducing our carbon emissions. Another thing that has carbon in it is methane, which is actually CH4, and water vapor is another greenhouse gas. So not too much we can do about water vapor, that's always been there, but we're really turning up the amount of carbon dioxide and methane in our atmosphere, which is leading to a much, much hotter planet. But we kind of need these things. We need greenhouse gases in order to keep our planet at a relatively safe and habitable temperature. So without these greenhouse gases, we'd be in some real, real deep trouble. We wouldn't really have an atmosphere, and our temperature would go down to about 0 degrees Celsius. So they keep us nice and toasty warm. I like to think of greenhouse gases as kind of like a blanket. So you know when you're in bed at night, you put the blanket on and you start getting hotter and hotter and hotter. Well, why is that? Well, what's happening is because when you put that blanket on, your energy, the heat that you're giving off, instead of going off into space in your room, leaving, it gets trapped inside this blanket. So it heats you up. And then you get a little bit hotter and you emit more heat. And then that also gets trapped and you get hotter and hotter and hotter. And you're creating this little oven inside your blanket, which keeps you nice and toasty warm and gives you a wonderful sleep. See, Earth is just like that, except instead of a blanket, we have all of these gases that make up our blanket. So what happens is energy from the sun, that's step one here, comes into the Earth, and lots of that energy gets absorbed. Some of it hits the Earth and bounces back into space. Cool. But what happens is it hits all these greenhouse gases. So sometimes it gets through and goes back into space, but lots of times some of that heat gets trapped inside here and bounces right back down to Earth again. And then that process repeats. So some of it will be absorbed, some of it gets released, and it would bounce back and forth, gradually heating up the Earth. And this is a normal and a very good thing, except it becomes much worse if we have too much greenhouse gas in the atmosphere. Because then it's like, instead of having one blanket, it's like having 3 or 4 blankets. And then that's way too hot, and then you got to put your foot outside while you're sleeping, and then the monsters get you, and that's not what you want. So we want to keep our greenhouse gases in check. If we have too much greenhouse gas, it's not going to allow our energy to escape out to space, and a lot of it's going to get trapped inside here and heat up our Earth. That has led to global warming. That's what we call the enhanced greenhouse effect. Some people also call it the anthropogenic greenhouse effect, which is a fancy word for human-made. But if you take a look, our global change in temperature, we have lots of different cycles on planet Earth, and temperature is one of those things. But we've never seen such a drastic increase in temperature than we have over the last little while. And people are getting really worried, as they should be. We're going to talk a lot about global warming in the coming days and weeks of this course, but it's just a good idea to be aware that it is due to an enhanced greenhouse effect, so us pumping more and more greenhouse gases into the atmosphere and basically making a thicker blanket. So some effects of global warming: we have rising sea levels. Obviously, the ice caps are melting, and I'll show you some pictures later on when I come back of some of the evidence we saw in Iceland about that. Some countries are getting super hot and hotter than they've ever been before, and you'll notice even in the last couple years that there's been tons more storms than we're used to, and that's attributable to global warming. So global warming is causing some really unpredictable weather, and it's really just getting worse, which is the unfortunate part about that. So I'm just going to leave this up. I'm not going to talk too much about it because I like to talk about it when I get back. But this is the one thing you may notice is this. If we go up 6 degrees Celsius, mass extinction, which is really bad. Even up to 5 degrees, tsunamis generally aren't the coolest thing in the world, and most of the world being uninhabitable doesn't set up so well. But 6 degrees, well, it's really not so good. So right now we're at about 1.8 degrees, which isn't so good. And that's kind of what we're seeing. So if we go up another 1 degree, we're going to get some of this. But we'll talk about that when I get back. This slide you do not need to copy, so congrats. You can put an X through that. I will not be asking you about any of this stuff. I will, however, be asking you about acid rain, which is not the best thing ever. When people hear acid rain, they think of like rain coming down and touching their skin and like melting them. That's not what it is. In fact, most rainwater and most water you get out of your tap is actually naturally a little bit acidic. Some of it actually sitting at about a 5.4 in terms of acidity. Acid rain is even more acidic than that, and it happens when we have nitrogen oxide and sulfur dioxide being released into our atmosphere. So we get a lot of these things happening from factories and industrial production. So we get lots of nitrogen oxide and sulfur dioxide being released up into our atmosphere. When they get up there, they mix with some of the gases and water in the atmosphere, and we actually end up with nitric acid and sulfuric acid. Not the cutest two things to have in your rainwater. So these things are just hanging out up there. Eventually they got to get back down to Earth. So they come back to Earth in the form of rain or snow or hail or whatever you'd like to call it. But it results in a lower pH, which means more acidic. The lower your pH, the more acidic you are, which leads to the phenomenon called acid rain. So when we get this nitric acid and sulfuric acid, we end up with acid rain. All right, so you can see what's happening here. Nitric oxide and sulfur dioxide go up, they combine with some stuff in the atmosphere, and we get nitric acid, sulfuric acid, and that leads to our acid rain, acid snow, or acid gas. You might not be able to tell the difference between regular rain and acid rain, but you know who can? Is lots of small little creatures like fish or plants. They really don't like acid rain and they can notice the difference. And it leads to a lot of destruction in their ecosystems. In fact, if we have acid rain happening, lots of plants and animals can't survive at all. And if they do survive, things like crabs might have, or shellfish, might have very, very weak shells, which make them very susceptible to predators. So it causes a lot of really damaging effects. Okay, pH. So most rainwater, like I said, is at about a 5.4. We can bring it all the way down to pretty close to a 4 if we have very severe acid rain. Not good, and we do not want that at all. We'll be taking a look at some charts about what kind of organisms can deal with that, but a pH of 4 will kill a lot of our ocean life. So we really don't want that. We want to keep it around where it naturally is supposed to be. Okay. All right, I talked about all of these things, so I'm not going to spend too much time on them. Soils are bad, fish are bad. It's bad for pretty much every small plant or fish that has to deal with the effects of acid rain. It provides zero benefit to any of them. So it's something we really got to watch for, and that's why there's lots of government initiatives to reduce the amount of greenhouse gases, specifically when we're talking about nitric acid and sulfuric acid being formed in our atmosphere. Just like this, we have Ontario's Drive Clean program. So before I started driving my sweet Toyota Camry, I used to have an Oldsmobile, which was a really ballin' car back in the day, and it was awful. Like the thing would barely start, and I was super worried because I had to pass this thing called Ontario's Drive Clean, and if you don't pass it, your car just doesn't get on the road. And I remember taking it to the sketchy mechanic and like just praying that, because I was a struggling student, I'm like, I don't have the money to fix this thing. And he gave me the go ahead, and I was so happy. But the car only lasted for another 2 months before I had to get another one. So the Ontario's Drive Clean program is done to ensure that we have clean air as best as we possibly can. And that happens a lot of the time through monitoring these old cars and making sure that they're up to snuff. And that is it. I will be seeing you guys on Monday. Please use tomorrow to review and complete all practice quizzes that you have not completed. All right, we'll see you.